8.6. This is number 301, and we're asked to analyze the graph of y equals cosine x divided by x over the interval minus 2 pi to 2 pi without using a calculator. So first of all, let's look at the domain here. Let's keep this simple. Cosine x divided by x. Of course, we cannot divide by 0, so this is undefined at 0. So let's just quickly write the domain here. Since we're only looking for minus 2 pi to 2 pi, we'll just write it this way. It goes undefined at 0. Now we can go ahead and look at, see if there's any asymptotes at x equals 0. And the assumption, or let's say the intuition, is probably that there's a vertical asymptote. But let's take a look at the limit as x approaches 0 from the right-hand side of cosine x over x. Now, at 0, cosine of 0 is just 1, so this is really the limit as x approaches 0 from the right of 1 over x. And of course, as x gets smaller and smaller, still positive, this is just going to blow up toward infinity. Similarly, if we have the limit as x goes to 0 from the left of cosine x over x, since cosine of 0 is 0, then cosine of 0 is 1. So the limit as x approaches 0 from the left of 1 over x. Now, x is approaching 0 from the left, meaning it's small and still negative. So this will blow up to minus infinity. So we have a vertical asymptote at x equal 0. Now, let's see here. On the right-hand side, I think I want to just look at the cosine functions. We're going to keep things basic here. So y equals cosine x, and looks like that to 2 pi. Again, this is a rough sketch, so, and looks like that to minus 2 pi. Now, our function is not the cosine function, or else this would be pretty simple. Notice that our function has a divide by x. So, as the cosine function goes further out to the right, I'm dividing the numerator by a larger and larger number. If this were to go on forever, then I would have a horizontal asymptote, which would be the x-axis. This would tend towards 0, because cosine fluctuates between minus 1 and 1. And as x gets bigger, I'm dividing by a larger and larger number. So what's going to happen is that part of the denominator divided by x is going to taper this down. Same thing on the left-hand side, it will taper it down as well. So I'm just going to draw on the right-hand side first. All right, and so now we know it's a vertical asymptote, and from approaching from the right-hand side of 0 goes to infinity, so it's going to do this, and then it's going to do something like that as it tapers off towards 0. Okay. Now what's going to happen on the left-hand side? I do need to look at symmetry, because it's not going to inherit this even symmetry of the cosine function. Let's just test the symmetry. So over here, I'm going to look at y. I'm going to put a negative x into the function and trace and see what happens when I put a negative x in there. So when I put negative x into the cosine x over x, there's my input, negative x, but cosine is an even function, so cosine of negative x is the same thing as cosine x. So this is really just the opposite of the original function. So this means y at negative x is negative y, which makes this an odd function. So whatever happens on the right-hand side, this will flip the sign on the left-hand side. So it'll come down from below and do the same tapering out on the left. Okay, so that was not a very good graph, so I'm going to attempt to redraw that. Let me erase some of these other things here. So I'm going to try to draw this a little bit more accurate. So on this side, it's doing something like this, and on this side, it's doing something like that. Okay. So over here, I'm going to have a local minimum. Over here, I'm going to have a local max. And because of the odd symmetry, if I know the coordinates here, then I'll just literally change the sign on both the x coordinate and the y coordinate, and that'll give me a local maximum over here. And this local minimum over here, if I change the sign of the x position and the y position, that will give me a local minimum over here. Oh, and I can't write today, so let me erase something here. This is a local max over here. Alright, so if we can understand the right-hand side of this graph, then we, for free, get the left-hand side of the graph. Alright, so now let's go about finding the extrema. So y equals cosine x over x. And so I'll differentiate this. And so I'm going to call the numerator f and the denominator g. And so I'm going to use the quotient rule here. Okay, so f is the cosine function and g is just the linear function x. So f prime will be minus sine. And then g is just the function x minus, keep the numerator function, which is cosine x, and differentiate the denominator, which will be 1. And then I'll divide that by the denominator squared, which is x squared. I have a negative here in the first term, and a negative here, so I can factor out the negative sign. That makes things a little bit easier here. Okay, so I've got, there's my derivative. Now I know that the denominator can't go to 0, but my original function wasn't defined at 0 either. So on the domain in question, we only need to look at the numerator and set this to 0, which we're trying to find x sine x plus cosine x. Where does that go to 0?